We're going to look at global extrema or absolute extrema. The extreme value theorem states that if f is defined and continuous on a closed interval a, b, then f has a global max and a global min on that interval a, b. And it's either going to happen at a critical point or at an end point on that interval. So let's look at just a couple of graphs before we think about this theorem. If you look at this first graph, this point here is a local max, and this point is a local min. But if we see this graph is increasing on both ends, so that means that this local max is not a global or an absolute max because the graph keeps increasing past that local max. However, this local min, the graph does not come back down below the local min, so this local min is a global min. On this second graph, if we look, here is a local min, and here's a local max. If we look at the ends of the graph, here the graph is increasing and decreasing. So that goes past the local max and the local min, so that means that this graph has no global max or min. Because on the left-hand side, the graph is increasing to positive infinity past the local max. On the right-hand side, the graph is decreasing to negative infinity past the local min. So we could have both of these situations and some others if we're thinking about the whole graph. So what the extreme value theorem is saying, it's saying, well, let's only think about part of a graph. Let's think about a closed interval of the graph where the function is both defined and continuous on that interval. So for example, for graph number 3, let's look at the closed interval from a to b, where a is going to be 1 and b is going to be 5. And I'm going to look at the point values for our function at 1 and 5, or the function values. The extreme values theorem is saying ignore everything outside of that interval. So we're ignoring all of this, and we're only looking at the graph on this particular interval. So we're only looking here. The extreme value theorem says that on that closed interval, we definitely have a global maximum and a global minimum. So if we think about the maximum for this graph, the global maximum, that means the highest point on the graph for this interval, that ends up being an end point. That's our global max, the highest value. And our global min is the lowest point on the graph, which is this critical point. So when we're looking at the whole graph, like examples 1 and 2, we will not necessarily have both a global max and a global min, but if we're looking at a closed interval, we definitely will have both. So in example 3, we have both a global min and a global max, and they must happen at either a critical point or an end point. In this fourth example, we're going to look at the closed interval from -1 to 3, and we're going to ignore the rest of the graph. Okay. So here is our graph, our section of the graph that's continuous and defined that we care about. And on that interval, we have a couple bumps. So we maybe have some local mins, local maxes in here, but what we're looking for is the global min and the global max. And here is the highest point on the graph, so that is the global max. And then here the other endpoint is the global min. So it is possible for both of these points to be endpoints. Or, as in example 3, it's possible for one or more of them to be one of the critical points. On a closed interval, we can always find a global min and a global max.